Hi students, today we are going to discuss about the engineering chemistry, unit 1, water chemistry. So, what is the meaning of water technology? Water technology means the process of removing all types of impurities from the water and making it fit for the domestic as well as the industrial purposes. So before going to the water technology, what are all the various impurities present in that water? So generally we know the water we have to taken from the ground and different sources, lake, well, sea water. So in all the waters are mainly contaminants are present. So in that contaminants we have to see one by one. So water is the most important component of the essential for our human beings and animals and plants. So about 80% of the earth surface is occupied by the water. So remaining 20 percentage has the land. So the main sources of the waters are the rainwater, river, lake. So river and lake water we are called as the surface water because they are standing in the above the land surface. Then another two types is the wells and the springs. So well water and the springs are the underground water. So based on the aquifer from the under the earth. Then last one is the sea water. So these are the different sources of the water. So in this source, the rainwater is the very pure form, but the collection of the rainwater is very difficult one, and all the 365 days not a rainfall is occur. So particular season only rainfall occur. So in that the collection is very difficult. So the rainwater is the pure form, but collection is very difficult. Same thing like is the river and the lake waters are the impurities water, because the river water and lake water contaminate the ground to contaminates the salts like the magnesium, calcium, sulfate, chloride, fluoride, other types of the salts are contaminated into the river water and lake. The well and the spring water is also the impure water because some of the salts are mingled with the well and the springs. Sea water is the highly salt content, so it unfit for the domestic as well as the industrial purpose. So this type of the water we have to purify it with some technologies, that is called as the water technology. So once again I repeat the definition for the water technology. So what are all the various impurities present in the water? In that impurities we have to remove, and the water it can be making it fit for the domestic as well as the industrial purposes. That is called as the water technology or water treatment process. Okay. Okay. So already I discussed the source of water. So here some picture is given. So rainwater, the pure but contaminated with gases. The same thing like is the sea water is the contain high salt content because through the river, through the channels, all the salt dissolved in that to mingle with the sea water again and again, so that the sea water is highly salt content. Okay. Then surface water and underground water, river water and lake water are the containing high different types of the salt content. Same thing like as the crystal clear the but contain high salt content in the underground water also, because the soil containing the high amount of the salt atoms and molecules, so many elements are mingled with that water to become the contaminated. Okay. So next we are going to the hard water and soft water. So what is mainly called as the hard and the soft? What is hard water? What is soft water? The hard water means it does not produce lather with a soap solution. Suppose we have to treat with the soap. If there is any foam occur, foam means lather. In that water we are called as a soft water. Absence of the foams, absence of the lather, that is called as the hard water. So this hard water is mainly due to the two main element like as the calcium and magnesium. So if the water containing calcium and magnesium in that water, we are called as the hard water. Absence of the calcium and magnesium, that is called as the soft water. So the hard water and soft water mainly distinguish with the presence of the calcium and magnesium. So in generally water which easily produce lather with the soap solution, that is called as the soft water. Water which does not produce lather with the soap solution is called as the hard water. The reason for the hard water is the presence of calcium and magnesium salts. Reason for the soft water, absence of the calcium and magnesium salt. So these are all the some of the difference between hard water and soft water. So here I given one reaction. What is the formula for the sodium soap? Sodium soap means C17H35 COONA, that is the sodium salt. So the esterate form of the sodium salt is called as the sodium soap. It is the water soluble component. So suppose if the water containing calcium 2 plus, what will be happen? Calcium soap is formed. So calcium soap we are called as the scum. Scum means precipitate. So if the water containing any calcium and magnesium that react with the sodium soap to form as the scum or white precipitate, so it is the not form any foams or lather. So that is called as the scum or precipitate. So this reaction is due to occur if the water containing the calcium or magnesium salts. Then salt water, already I told, salt water produce lather with easily in a soap solution. So this is due to the absence of calcium and magnesium salts. Once again I repeat, so hard water means does not produce lather with the soap solution. Soft water means easily produce lather with the soap solution. So hard water, presence of calcium and magnesium salts, but in the soft water, absence of calcium and magnesium salt. Are you understand? Okay. So here I given one picture. So here two conical flasks containing the water solution. So in the first solution we are called as the soft water because we have to treat the water into the soap solution to form the foam or lather. So if the water produce easily foam or lather, in that water we are called as the soft water. But in the second conical flask there is no formation of the any foam or lather. So to form the precipitate like substance, so settled substances, like because due to the calcium and the magnesium salts does not form any foam because you treat with the soap to form the scum like substances or precipitate like substances. So it is the diagrammatic representation and explanation of the hard water and soft water. So the first water is called as the soft water, second water is called as the hard water. In soft water easily produce foam and lather, but in the hard water does not produce lather. In first soft water, absence of calcium and magnesium salt. In hard water, presence of the calcium and magnesium salt. Okay. Okay. Now we are going to the some properties of the water. The first property is the hardness. So hardness means it is the property of water or characteristics of the water which does not produce lather with a soap solution. So hardness is the very important property of the water, does not produce a lather with a soap solution. So how to detect the hardness? When the water is treated with a soap solution, if it form white scum, so already I told white scum means precipitate in the water, we are called as the hardness water. So the hardness is mainly due to the calcium and magnesium salt. So hardness is the property of the water does not produce lather with the soap solution due to presence of calcium and magnesium salt to form the scum-like substances or precipitate-like substances. Next, water containing hardness, it gives the wine red color with the eriochrome black tea indicator. So the pH level is highly basic nature 9 to 10. Suppose if the water containing calcium and magnesium, how can we detect the calcium and magnesium salt in that water? Suppose in that water we have to treat it with the ammonia buffer. Ammonia buffer means ammonia chloride and ammonium hydroxide. That is called as the basic buffer, weak basic buffer. So the pH range of that weak base pH is called 8 to 10 pH range. Suppose in that water we have to react with the ammonia buffer and EBT indicator, that is called eriochrome black tea indicator. So in that water produce wine red color in that indicator. So the definitely in that water containing calcium and magnesium salt. Okay. So it is the two method to detect the hardness of the water. The first method is the with the soap solution which does not produce any lather or foam with water solution, that is called as the hardness. Second treatment is the wine red color which easily produced with eriochrome black tea indicator with ammonia buffer. So these are all the two detection method of the hardness in the water. So in examination point of view, they ask how can you detect the hardness of the water. So you have tried the 2 points. One is the if the water containing hardness does not produce lather with the soap solution, the first point. The second point which produce wine red color with the EBT indicator. So these 2 points are the detection of the hardness in the water sample. Okay. Next we are going to the types of hardness. So based on the salt content in that water, we have to distinguish two types of the water. One is the temporary hardness water, the other one is the permanent hardness water. How can we find out the temporary hardness and permanent hardness? We will see one by one. So depending upon the types of dissolved salts present in that water, we are classified. One is the temporary, another one is the permanent hardness. First we are going to see about the temporary hardness. The another name of the temporary hardness, carbonate hardness or alkaline hardness. Carbonate means CO3 2 minus or HCO3 minus. CO3 2 minus we are called as the carbonate anion, and HCO3 minus we are called as the bicarbonate anion. Suppose if the calcium and magnesium salt or ion mingled with carbonate, these are called carbonate hardness. The another name of the carbonate we are called as the alkaline. Alkaline means basic in nature. So the temporary hardness is due to the presence of bicarbonates of calcium and magnesium. Bicarbonate means HCO3 minus. How can we remove the temporary hardness? It can be removed by boiling the water and adding lime to the water. Suppose if the temporary hardness containing the carbonate salt, just we have to boil it in that water, the carbon dioxide gas which easily evolved. So the first reaction represents calcium bicarbonate. You have to boiling CaCO3, calcium carbonate precipitate will occur, then water is formed and carbon dioxide is formed. So in that carbon dioxide which is easily evolved from the solution even at boiling. So this type of hardness we are called as the temporary hardness. So carbonate salt containing the carbon dioxide which easily evolved or removed even at the boiling, so that it is called temporary hardness. So another method to remove the temporary hardness is by adding the lime. Lime means calcium hydroxide. So calcium hydroxide we are called as the lime. So by adding lime into the temporary hardness producing water to form the magnesium hydroxide precipitate and also the calcium carbonate precipitate and water. So in that precipitate we have to easily removed from the water. So these are called temporary hardness producing salt. So these are the two methods to removing the temporary hardness, even at boiling by adding the lime. So these two process is the removal process of the temporary hardness. Okay. Now we are going to the next type of the hardness, permanent hardness. So another name of the permanent hardness, non-carbonate hardness. So here the absence of the carbonate salt, so it is called non-carbonate hardness. Another name of the permanent hardness is called as a non-alkaline hardness. Non-alkaline hardness. So this is due to the presence of chlorides and sulfates of calcium and magnesium. So permanent hardness is mainly mingled with the chlorides and sulfates of the calcium and magnesium. For example, calcium react with the chloride to form the calcium chloride, and calcium react with the sulfate to form calcium sulfate. The same thing like as the magnesium react with the chloride to form the magnesium chloride, and magnesium react with the sulfate to form as the magnesium sulfate. So here I told four salt. What are that? Calcium chloride, calcium sulfate, then magnesium chloride, magnesium sulfate. So these four salts are the mainly produce the permanent hardness or a non-carbonate hardness or non-alkaline hardness. Once again I repeat, the presence of chloride and sulfate salt react with the calcium and magnesium to form the permanent hardness. These are all the calcium chloride, calcium sulfate, and magnesium chloride, magnesium sulfate. Okay. Then how can we remove the permanent hardness? So it cannot be removed by boiling the water, but it can be removed by two process. One is the lime soda process, another one is the zeolite process. What is the lime soda process? Suppose if the water having the permanent hardness like the calcium chloride is the permanent hardness producing salt in the hard water. We have to add the soda. Soda means sodium carbonate, Na2CO3. So which form the calcium carbonate and NaCl. So in that calcium carbonate we are called as the temporary hardness. So it is the process to convert the permanent hardness into temporary hardness. In the temporary hardness we have to boiling, which easily removed. So the lime soda process is another way is called as the conversion of permanent hardness into temporary hardness. Calcium chloride is the permanent hardness producing salt. So after treating the calcium chloride into the soda, that means Na2CO3, it converted into calcium carbonate. So the calcium carbonate is the temporary hardness producing salt. So even at the boiling of the calcium carbonate, which is easily removed from the water. So the lime soda process is the very important to conversion of the permanent hardness into temporary hardness. Okay. The next method, zeolite process. What is zeolite? So zeolite is the hydrated form of sodium aluminosilicate. Once again I repeat, what is zeolite? Hydrated form of sodium aluminosilicate. The molecular formula for the zeolite is Na2O, Al2O3, X SiO2 dot Y H2O. So another name of the zeolite is hydrated form of sodium aluminosilicate. So we have to simply write as the Na2Ze. Here Na2 is the sodium, Ze is the zeolite. It is the sodium zeolite. What is that? Sodium zeolite. Suppose in this sodium zeolite treated with the permanent hardness producing water, that is the calcium sulfate. So in that sodium zeolite converted to calcium sulfate to calcium zeolite. So instead of sodium zeolite, it is formed as the calcium zeolite. So in that zeolite absorb the calcium and magnesium salt from the water and to form the Na2SO4. So it is the another method to conversion of the permanent hardness producing salt into normal water. That is the calcium sulfate converted into the calcium zeolite and Na2SO4. So these two methods are used to removing the permanent hardness producing salt in the water. Okay. So now we are discussed what is the meaning of temporary hardness and what is the meaning of permanent hardness. The temporary hardness producing salts are the bicarbonate salts of the calcium and magnesium. Example, calcium bicarbonate, magnesium bicarbonate, calcium carbonate, magnesium carbonate. So these four salts are the temporary hardness producing salt. Why we are called as the temporary hardness producing salt? Even at the boiling, so the carbonate salts are easily evolved, removed from the water, so that we are called as the temporary hardness producing salts. The another name of the temporary hardness producing salt is the carbonate hardness or alkaline hardness. How can we remove the temporary hardness producing salt? First point is the by boiling the water. Second point is the lime soda process. Okay. Then permanent hardness producing salt. What is the meaning of permanent hardness producing salt? Permanent hardness producing salt. The calcium and magnesium react with sulfate and chloride salts. Sulfate and chloride salts react with the calcium and magnesium to form the calcium chloride, calcium sulfate. Then magnesium chloride, magnesium sulfate. So these four salts not containing any carbonate salt. So these salts are called as the non-carbonate hardness or non-alkaline hardness. So even at the boiling there is no removal process occur in that water, so that we are called permanent hardness producing salt. So how can we remove the permanent hardness producing salt? Here I given the two method. One is the lime soda process, another one is the zeolite process. So using these two process we have to easily removed from the calcium and magnesium salt from the permanent hardness producing water. Okay, are you clear? Okay. Then what is the meaning of total hardness? Total hardness means by adding the temporary hardness and permanent hardness, it is called as the total hardness. So in that total hardness containing 8 salt. Suppose if the water containing calcium carbonate, calcium bicarbonate, magnesium carbonate, magnesium bicarbonate. So these four salts are the temporary hardness producing salt. Suppose if the water containing calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. These four salts are called as the permanent hardness producing. So by adding these two temporary and permanent, we get the total hardness. So in the total hardness, normally 8 salts. So by adding temporary and permanent is called as the total hardness. So totally 3 types of the hardness. One is the temporary hardness, another one is permanent hardness, then last one is total hardness. Suppose if the water containing total harness and the permanent harness. How can we detect the temporary harness? Temporary harness equal to total minus permanent. Okay. How can you detect the permanent harness? Permanent harness equal to total harness minus temporary harness. So by simplifying the formula, we have to detect the any one of the harness. If you know any two types of the harness in that water, so based on that two types of the water, we have to detect the third term of the harness. Okay. Are you clear the types of the harness? Yes. Then another important units of harness. How can we put the different units of the harness? So the first unit is the ppm. ppm means parts per million. So the number of parts of calcium carbonate equivalent to harness per 10 to the power of 6 parts of water. 10 to the power of 6 means 1 million part. So if the water containing any type of the harness, the one part of the solute or contaminate or impurity present in 1 million part of the solvent, that is called as the parts per million, or we are easily can be calculated as the milligram per liter. Milligram per liter means another unit of the harness. The number of milligram of calcium carbonate equivalent to harness per 1 liter of the water. Suppose in water 1 milligram of the any type of the harness producing salt dissolved in 1 liter of the solvent or water, they are called as the in that water 1 ppm. Suppose 2 milligram of the salt dissolved in 1 liter of the water, that is called as the 2 ppm. Same thing like the suppose 10 milligram any type of the harness producing salt dissolved in 1 liter of the water is called as the 10 ppm. Okay. So 1 ppm means 1 milligram solute or 1 milligram impurity dissolved in 1 liter of the solvent. 2 ppm means 2 milligram. Suppose 5 ppm means 5 milligram of the any type of the impurity dissolved in 1 liter of the solvent, that is called as the 5 ppm. So these two units are the predominantly we have to use to detect the hardness. One is the ppm, another one is the milligram per liter. Then third unit is the Clark's degree. So the number of parts of calcium carbonate equivalent to hardness per 70,000 parts of the water, that is called as the Clark's degree. Then last one is the French degree. The number of parts of calcium carbonate equivalent to 10 to the power of 5 parts of the water is called as the French degree. So what are the relationship between the various units? 1 ppm which is equal to 1 milligram per liter, which is equal to 0.1 degree French, and which is equal to 0.07 degree of the Clark's degree. So why we have to take in here calcium carbonate equal to because calcium atomic number is the 40, carbon atomic number is the 12, then oxygen atomic weight is the 16. So 3 into 16 48 plus 12 plus 40, totally the molecular weight of the calcium carbonate is the 100. So 100 is the round up value, so that we have to take in as the calcium carbonate equivalent. Once again I repeat, why we are taken as the calcium carbonate equivalent to detect the unit of the hardness. The molecular weight of the calcium carbonate is 100. How can we calculate the molecular weight of the calcium carbonate? So the atomic weight of the calcium is 40. Okay, atomic weight of the calcium is the 40. Then atomic weight of the carbon is 12. So the 40 plus 12, how much? 52. Okay. Then atomic weight of the oxygen is the 16. So here 3 oxygen atoms are available, CO3. So 3 into 16, 48. So already I told calcium 40, carbon 12, 52. The 52 plus 48, 100. So the molecular weight of the calcium carbonate is 100. So that we have to take as the calcium carbonate equivalent. So remaining salts the not form as the 100 value. So that which is easily calculate the hardness of the water using the formula calcium carbonate. So that we are taking as the calcium carbonate equivalent in the detection of the hardness or to detect the units of the hardness. Okay, are you clear? So in the today's class we have to see about the introduction about the water technology. What is the meaning of water technology? Water technology means the removal of the all types of the impurities from the water and making it fit for the domestic as well as the industrial purposes. Okay. Okay, then we were seeing about the different sources of the water: rainwater, groundwater, surface water, underground water, then sea water. The rainwater is the pure form, but the collection of the rainwater is very very difficult one, and the groundwater and underground waters are the very impure one, but it does not making it fit for the domestic as well as industrial purposes. So that we have to treat the groundwater and underground water. Then another one is the sea water. Sea water is the highly salt content. The sea water also not fit for the any purposes. So that we have to treat the water and making it fit for all the purposes. So that it is called as the water treatment process or water technology. So before going to the water technology, what are all the impurities present in that water? So in that water you have to classify into the two types. One is the soft water and another one is the hard water. Soft water means the water which easily produce lather with the soap solution because the absence of the calcium and magnesium salt. And the hard water means does not produce lather with soap solution due to the presence of calcium and magnesium salt. Okay, then we were discussed about the hardness of the water. Hardness is the property of the water which does not produce lather with the soap solution to form the scum like substances with the soap solution. And we are classified into the two types of the hardness. One is the permanent hardness, another one is the temporary hardness. Permanent hardness means calcium and magnesium react with the chloride and sulfate to form the calcium chloride, calcium sulfate, magnesium chloride, magnesium sulfate. So this another name of the permanent hardness is called as the non-carbonate hardness or non-alkaline hardness. So the same thing like as the temporary hardness. Temporary hardness means bicarbonate salts of the calcium and magnesium. Bicarbonate salts of the calcium and magnesium. For example, calcium bicarbonate, magnesium bicarbonate, calcium carbonate, magnesium carbonate. So these are all the two types of the hardness. How can we remove the two types of the hardness? So in the temporary hardness, even at the boiling, we have to easily remove it from the water boiling process and by adding the lime. Then second, how can we remove the permanent hardness? In the permanent hardness, we have to remove the lime soda process. Another one is the zeolite process. So using these two method, we have to remove the permanent hardness producing salt from the water. So by adding the permanent hardness and the temporary hardness, we are called as the total hardness. Then last one is the units of hardness. We have to see in one by one. One is the parts per million, then milligram per liter, then French degree and Lex degree. So these are all the today's covered topic. So if there is any doubt, you have to individually ask me. You have to clarify the doubts. Okay, thank you.